All right, finishing up number 11, parts E and F. So for part E, inside the parentheses, the x to the 7th over x squared, before we even apply this exponent right here, let's ignore it. So cover it up. If I had to simplify x to the 7th over x squared, I can use my division property of exponents that says if they have the same base and I'm dividing, all I do is subtract the exponents. So 7 minus 2 is 5. So if I rewrite my expression now, in fact, I'm just going to use my eraser here. Instead of x to the 7th over x squared, I'm going to replace it with x to the 5th. So now if I simplify my expression, I'm applying another property. I have a power raised to a power, and if I have power raised to a power, the property says that we multiply the exponents. So this is 5 times negative 2, which is negative 10. Your final answers cannot have a negative exponent. How do you get rid of a negative exponent? If this were to the positive 10th, this would be my answer, but it's not. It's to the negative. So you take the positive exponent. If it's not a fraction, put it over 1, and you find the reciprocal of that. So it's 1 over x to the 10th. For part F, there's really a couple ways you can do this. I would focus on the numerator first. So looking at the numerator, I have the multiplication property of exponents that I'm going to apply here that says if you're multiplying and they have the same base, the base is x, you add the exponents. So 4 plus a negative 3, or really you're saying 4 minus 3 is 1, or x to the 1st. This is all over x to the 10th. So from here, really I would suggest, if you notice the denominator has more x's than the numerator, instead of applying the division property where you subtract the exponents, if you guys remember I told you if you expand the numerator and denominator, where would you have more x's when you cross them out? You would be left with 9 x's in the denominator. So really this is 1 over x to the 9th.